In your work, both with number and algebra, you're going to need to be very familiar with exponential notation. Now you really should be quite familiar with exponential notation, but let's just recap it. 5 to the power of 6 just means that you have 6 5s that are multiplied together. So that's 5 times 5 times 5 times 5 times 5 times 5, and that gives you, if you work it out, 15,625. You've done a lot of work already with squares and cubes, so you know, for example, 5 squared just means 5 times 5, and 5 cubed means 5 times 5 times 5. So this one is 25, and this one is 125. And I've suggested before that really being able to recognize these square and cube numbers is quite useful. So just knowing immediately that 16 is 4 squared or 216 is 6 cubed is going to be quite useful for you. It's also probably quite useful to know things like, for example, 2 to the power of 4, which we know is 2 times 2 times 2 times 2 is going to be 16, and 2 to the power of 5 is just going to be 16 times 2, which is 32. So recognizing those numbers is going to be quite useful for you to do. But you can, of course, always work it out. Let's just emphasize the difference between multiplying by a number and raising to a power. So what's 2 times 5 plus 2 times 4? Well, 2 times 5 is 10, and 2 times 4 is 8, and so in total here I'll have 18. In contrast, over here I have 2 to the power of 5, so what does that mean? That means that I have got 2 times 2 times 2 times 2 times 2. And then I add to it 2 to the power of 4. That's 2 times 2 times 2 times 2. So 2 to the power of 5, 2 times 2 times 2 times 2 times 2, that's 32. 2 to the power of 4 is 2 times 2 times 2 times 2 times 2, which is 16. So what I have here is 16 plus 32, which is 48. So very important to notice that 2 to the power of 5 is not the same as 2 times 5. 2 to the power of 5 means 2 times 2 times 2 times 2 times 2, which is very different to just saying 2 times 5. Now let's have a look at how we might work out something like this. As you go on, we're going to look at rules and whatever for dealing with this. But something that I want you to remember always when you're dealing with exponents, which have whole number powers, is actually, it is very simple if you just write it out. So if you remember the little saying, if in doubt, write it out, you'll be fine, right? So with exponentials, you can always write out what's going there, and then you won't go wrong in your calculations. So let's have a look at 5 to the power of 6. What does that mean? Writing it out, it's just 6 5s all multiplied together. And what's 5 to the power 3? Well, it's just 3 5s all multiplied together. And what is 3 squared? It's just 3 times 3, and of course then we just have a times 3. Now we can easily start sorting this out, because this 5 will cancel with this 5 with this 5 with this. And so what we're left with at the top here is 5 times 5 times 5, which is 125. And here we have 3 times 3 times 3, which is 27. And so what we get as our answer is 152. The thing that people often go wrong with is instead of writing it out, they try and make up their own little rules. And so they'll say, well, 3 times 3 is 9, so this is 9 squared. Just write it out and you'll see that 3 squared is 3 times 3. And then there's another 3 times 3. And then you'll get to the right answer. Similarly, people will start to see, oh, can I just kind of do something with a 6 and a 3? Certainly for a long while at the beginning, just writing it all out will help you see exactly what is going on and prevent you from going wrong. Let's have a look at how negative numbers work when you raise them to a power. Let's look at these three numbers. And we're going to use our basic idea of exponents, which is, if in doubt, write it out. We're simply going to write out what they mean in order to help us work out what they're equal to. So 2 to the power of 4, we know that that is just 4 2's all multiplied together, and so we should know by now that that is 16. Now if we go to this one, note here the negative is not affected by the 4. What you've got is a negative in front of the number 2 to the power of 4. And we know 2 to the power of 4 is just 16, so we've got a negative 16. But if we want to write it out, just for completeness sake, what we'll see is we've got a negative, and then we've got 2 to the power of 4, which is that, and so what we've got is negative 16. This one, however, is very different, because what you've got is a negative 2 that's being raised to the power of 4. So it's this whole thing that's raised to the power of 4. So what you get is negative 2 times negative 2 times negative 2 times negative 2. So let's just recap our negative multiplication rules. Negative times negative is positive. Then we've got a positive multiplied by a negative, which is negative. Then we've got a negative multiplied by a negative, which is positive. And 2 times 2 times 2 times 2 is 16. So we know what we've got is positive 16. Okay, try this one for yourself. Pause the video and try it for yourself. Okay, so did you say this is negative 5 multiplied by negative 5 multiplied by negative 5? Negative times negative is positive, positive times negative is negative, so you've got negative 125. And what about if we had minus 1 to the power of 6? Well, that's going to be one, two, three, four, 5, 6 negative ones all multiplied together. And can you see what you're going to get here is negative times negative, that's positive, negative times negative, positive, negative times negative, positive. So in total you're going to be positive, and 1 times 1 times 1 times 1 is always just 1. So we're going to get positive 1. Can you tell me what you think is going to happen with negative 1 to the power of 7? Pause the video and think about the answer for yourself. Did you get that this would just be negative 1? Because what you're going to have is the same situation as here, with just 1 more multiplied by negative 1. The pairs are all going to end up as positive 1, and then you're going to multiply by a negative 1, which gives you negative 1. So you should be able to then quite easily think about if it was negative 1 to the power of 90, well, you're going to be able to make loads of pairs of negative 1s multiplied together, so you're going to end up with positive 1. But if you had negative 1 to the power of 103, you're going to have a whole lot of pairs, and then you're going to have 1 extra, negative 1 in your multiplication, and so it's going to be negative 1. We're going to discuss square roots and cube roots. We're going to start by looking at squaring, and the reason for this is that square rooting and squaring are kind of opposite, inverse relations to each other. So square rooting undoes what squaring does. Let me show you what I mean. If I ask what positive number, when squared, is equal to 25, I'm asking you, what positive number squared gives me 25? Hopefully that's easy for you by now. The answer to that is 5. And that tells me immediately that the square root of 25 is 5. So when we're asking for the square root of 25, we're asking what positive number, when squared, will give me 25. So if we start at the other end, for example, we ask, what's the square root of 49? What we're asking is, what positive number, when squared, will give me 49 as the answer? And that should easily be known to you as 7, and so the square root of 49 is 7. Now we could also ask some quite weird questions. If I asked you, for example, what is the square root of 53 times 53? Remember, what I'm asking you there is what positive number, when squared, will give me 53 times 53 as the answer? Well, what number must I put in over here to get 53 times 53 as the answer? The number I have to put in there is 53, because 53 squared means 53 times 53. So, the square root of 53 times 53 is 53. And we'll have a very similar story with cubes. And cube roots, if we ask what number when cubed is equal to 8, what we're asking, what number cubed gives us 8 as the answer. And you should know by now that that's 2 cubed. And so writing that in cube root form, that means the cube root of 8 is equal to 2. And we can start with the cube root sign again. So maybe let's say, what if we asked, what is the cube root of negative 125? Well, what we're asking is what number, when cubed, gives us negative 125 as the answer. And you should know that that is negative 5. And so the cube root of negative 125 is just negative 5. Now you might have noticed I was very happy to talk about negatives when I was dealing with cube roots, like cube root of negative 125 is negative 5. But I deliberately avoided talking about negatives when I was talking about square roots. Why is that? Well, let's think about square root of negative 25. I'm asking myself there, what squared will give me negative 25 as the answer? And I'm going to be stuck trying to get that answer, because a negative times a negative gives me a positive. So negative 5 times negative 5 will give me positive 25. And a positive times a positive also gives me a positive. So 5 times 5 will give me positive 25. So there's no option here. There's no solution to this. In the real number system, the square root of negative 25 does not exist. The other thing to take note of when we're talking about square roots is, look, negative 5 squared is negative 5 times negative 5, it's 25, and 5 squared is 25. So when we talk about the square root of 25, actually we could possibly either give 5 or negative 5 as the answer. But we didn't want to have that confusion in maths with one thing having two answers, and so we very deliberately say the square root of 25 is just the positive answer 5, and if we want to have the negative answer, we say negative the square root of 25, and then that comes up with your negative 5. Let's explore a few calculations where we have a number of steps in them, and also the order of operations, which we're going to summarize as BEDMAS. Let's have a look at how badly behaved addition and subtraction is in comparison to multiplication and division. So if we start with looking at the square root of 9 times 16. Right, 9 times 16, if you work it out, it's 144, and the square root of 144 is just 12. And you see what I mean by well behaved? if you could do that much more simply by just saying, okay, I've got the square root of 9 times 16. I'm then talking about the square root of 9 times the square root of 16. I can split that up very nicely, which is 3 times by 4, which is 12. All works beautifully. Now have a look here at what happens with addition. Okay, so here we're talking about 9 plus 16, which is 25. So we're talking about the answer here being 5. Now, let's have a look. Can we do the same story of just nicely splitting up? So can we say that this is square root of 9, I'm already getting to the answer there, square root of 9 plus square root of 16, which is 3 plus 4, and we get the answer of 7. Can you see you are not allowed to do that? With addition, you can't just split it up. So your multiplication is very nicely behaved. You can just talk about then the square root of 9, square root of 16. With addition, you can't do that. And you'll see a very similar story with subtraction. For example, if I talked about 4 minus 3 squared, well, what's 4 minus 3 squared? 4 minus 3 we know is 1, and 1 squared is just 1. Could we just say, okay, let's do 4 squared and subtract 3 squared? Well, let's have a look at that. We would have 4 squared subtract 3 squared, which is 16, subtract 9, which is 7. Again, you can see with subtraction, again, we can't just split it up and distribute it like that. So, short story, multiplication and division, no problem at all. Addition and subtraction, you need to be a little bit careful. Let's have a quick look at order of operations. We're going to use the acronym BEDMAS to help us remember the order in which to do things. We're going to deal with brackets, anything in brackets first. Then we'll have a look at exponents, and after that division and multiplication together, and after that addition and subtraction together. So if we look at a nice whole big monster like this one, let's first see where we're going to start. Square roots are exponents, so let's deal with this square root here. So, in order to deal with a square root, we know that we can't just say square root 100 square root 64 because we've got a minus sign, right? Remember, plus or minus, we can't just, they misbehave. We have to actually work them through first. So 100 minus 64, that's 36. And the square root of 36 is 6. And then we've got another exponent, 2 cubed, that's 8. And we'll deal with all the rest in the next line. Okay, BEDMAS tells me that after that, I must deal with my division and multiplication. So I am going to deal with my multiplication here first. So I'm going to have 6 plus 24. And then at the bottom of my fraction, I've got 9 minus 6 plus 3. So at the top of my fraction, I have 6 plus 24, which is 30. And at the bottom of my fraction, if I've just got addition and subtraction, I just work from left to right. So 9 minus 6 is 3. 3 plus 3 is 6. So I've got 30 over 6. And now 30 over 6, well, 30 divided by 6 is 5. Remember, your fraction line just means division. So 30 divided by 6.